Hey everyone, welcome back. In our last video, we tackled how to find eigenvalues of a 2 by 2 matrix. If you haven't seen that one yet, I'll link it in the description below. Today, we are taking the next step, finding the eigenvectors that correspond to those eigenvalues. Let's pick up right where we left off. Remember, we found the eigenvalues for our matrix A equal to 2, 1, 1, 2. Let's say lambda 1 is 3 and lambda 2 is 1. Now for each of these eigenvalues, we will find the corresponding eigenvectors. Eigenvectors are non-zero vectors that when multiplied by a matrix result in scaled versions of themselves. They are like the direction that the matrix stretches or compresses. To find them, we'll use the equation A minus lambda I times V is equal to 0. Here A is our matrix, lambda is the eigenvalue, I is the identity matrix, and V is the eigenvector we are trying to find. Let's start with lambda 1 is equal to 3. We'll plug this value into our equation and we get A minus 3I into V is equal to 0. That is 2 minus 3, 1, 1, 2 minus 3. V we will put as x1, x2. And 0 is going to be column matrix 0, 0. This simplifies to minus 1, 1, 1, minus 1, x1, x2 is equal to 0, 0. Performing on R2, R2 changes to R2 plus R1, we get minus 1, 1, 0, 0, x1, x2 and 0, 0. So therefore this results in minus x1 plus x2 is equal to 0. That is x2 is equal to x1. Therefore we get V is equal to x1 comma x1 where x1 is a real number. This is the eigenvalue corresponding to lambda 1 equal to 3. If we put x1 as 1, we get V is equal to 1 comma 1. Now let's repeat the same process for lambda 2 equal to 1. First, we plug lambda 2 equal to 1 in the equation and we get A minus 1 into I into V is equal to 0. This gives us 2 minus 1, 1, 1, 2 minus 1 into V, which is x1, x2 is equal to 0, 0. That is 1, 1, 1, 1 multiplied by x1, x2 is equal to 0, 0. On R2, we perform the elementary row operation R2 minus R1 and we get 1, 1, 0, 0, x1, x2 is equal to 0, 0. Therefore, we have x1 plus x2 is equal to 0, which gives us x2 is equal to minus x1. Therefore, we get v2 is equal to x1 comma minus x1, where x1 is a real number, is the eigenvector corresponding to lambda 2 equal to 1. Again, if we put x1 as 1, we get v2 is equal to 1 comma negative 1. To double check our work, we can multiply our matrix A by the eigenvectors V which we have found, and the result should be equal to the eigenvalue, that is lambda, times the eigenvector V. Let's verify for lambda 2 equal to 1. For lambda 2 equal to 1, the eigenvector is 1 comma minus 1. Consider the left side. So A was 2, 1, 1, 2. And V is 1 minus 1, and when we multiply this we get 2 minus 1 and we get 1 minus 2, which is equal to 1 minus 1, which is equal to 1 times of 1 comma minus 1, and that is equal to lambda into V. So thus we get AV is equal to lambda V. That's how we find the eigenvectors. It's a key step in understanding how a matrix transforms vectors. In our next video, we'll explore more examples on eigenvalues and eigenvectors. So stay tuned. If you found this video helpful, please like, subscribe and share it with your fellow math enthusiasts. Let me know in the comments if you have any questions and suggestions for future videos. Thanks for watching and happy learning.